Hello, children. I'm planning to put a short video, hopefully. Yeah. In chapter 3, machines. You have not written anything in the notebook. Yeah. So I thought I'll give a quickly all the important formulas and derivations. So as you watch this video, make sure you note down everything in your notebook. And you must send a copy of it before tonight. Okay, so as you watch the video, please keep taking notes and click a picture and send it to me. So in machines, what are the important terms? Load, effort, mechanical advantage, velocity ratio, and all that. Now take a simple example of a scissor. So first you saw the 4 uses of machines. Okay, so that I'm just doing only the important ones. So this is effort. If you're taking a scissor, then if this is the paper which is cut, that is the load. Okay, the force that you are applying is the effort and this is the load. Now this is the distance traveled by load and this is the distance traveled by effort. So how much force you are applying on the handle is the effort, and by how much distance will this move, that is distance traveled by effort. By how much distance the load moves is called dl. Okay, so okay, now we'll start with the main definitions first. First is mechanical advantage. Mechanical advantage, MA. The formula is load upon effort. So it is the ratio of load upon effort. You have to remember that. So in this, or L by E. Okay, this load upon how much effort we are applying. Now there is a special case if load is greater than effort. Okay, one of the use of a machine is to do a heavy work with a less load. Not this one. This one doesn't do that. Example, screw jack and all that. By applying small force, a big car can be lifted up. That means less effort, small effort, but greater load can be lifted up. If L is greater than E, then what will happen to mechanical advantage? Numerator is greater than denominator. MA will be greater than 1. Then it will act as a force multiplier. Force multiplier means it multiplies the force. A little effort is used to lift a heavy load. Is it clear, children? So if a load is greater than effort, MA is greater than 1, force multiplier. Come to the second one, velocity ratio. Velocity ratio, VR, distance traveled by effort upon distance traveled by load. Okay, this is effort in the denominator, this effort will be in the numerator, dE by dL. Now again, now I told you scissor doesn't do a heavy work. You cut a paper or a cloth, a paper you can cut it without a scissor also, but by using a scissor, what happens? Your work becomes faster. You move your effort only through this much distance, but your load will move through a long distance. So those are called speed multipliers. So if DE is greater than DL, or DL okay, no, DL is greater than DE. If DL is greater than DE, then VR will be less than 1. Yeah, DL will be greater means load moves through a long distance, whereas effort moves through less distance. DE is smaller, DL is bigger. Then VR is less than 1 because denominator is bigger and numerator is smaller. In that case, it is going to be used as a speed multiplier. Okay, if DL is greater than DE, VR will be less than 1, but it will be used as a speed multiplier. Why it is called speed multiplier? Effort moves through a small distance, but load moves through a larger distance. Okay. Now the third one, work input. Work input. So in this is input and this is output. So work input is force into displacement, that is load into distance traveled by, sorry, effort into distance traveled by effort. Fourth one, work output, that is load into distance traveled by load. Then fifth one, efficiency. Efficiency. Efficiency, eta is equal to work output upon work input. Then there is a derivation. I'll quickly do that. It's very easy. This is the relationship between MA, VR and efficiency. Relationship between MA, VR and efficiency. So you have to start from here. Efficiency is work output upon work input. Output should be in the numerator, input in the denominator. Now we know the formula for work output is L into DL, input E into DE. So I'm going to group them. L by E, bring it together. DL by DE, group them together. Now L by E is mechanical advantage, MA. So instead of L by E, I can write MA into DL by DE. DE by DL is VR. So DL by DE will be 1 by VR. So efficiency is equal to MA upon VR. This is the relationship between efficiency, MA and VR. So this derivation sometimes they ask you. Okay children. One more conclusion. Velocity MA, if MA is equal to, in ideal machine, MA will be equal to velocity ratio. Therefore, efficiency will be 100%. But in practical machines, okay, ideal machine means where there is no loss. Practical machine, MA will always be less than VR. So, efficiency will be less than 100%. Remember this. And always remember, MA will be less than, VR will never change. For a particular system, velocity ratio will remain the same. But MA keeps changing depending on the losses and all that. Okay. So that is, these are the important things in the A part. I hope you're noting it down along with me. Now, coming to the B part, pulleys. Pulleys. Okay. So there are two types of pulleys we are going to see. One is single fixed pulley. The other one is single movable pulley. Now, single fixed pulley means you will have a fixed frame and the pulley will, this is the axle. So the pulley, the axle of the pulley is fixed to this fixed frame. This is a fixed frame, a wooden bar or something. So this is the axle. Sorry, this is the axle. This one is the axle. And okay, this is the frame. Okay, this is the frame. So main thing is fixed frame and then axle. Okay, so the pulley is fixed through this axle to this fixed frame. That is, the pulley is fixed. Pulley will not move. It remains fixed and it will only rotate. When I say it will not move means it will not move up and down. Okay, it will be in its position and keep rotating. Okay, and this is the load, bucket or something, load, and here you apply the effort. Suppose you are drawing water, so this is the effort. So load will be acting in downward direction and effort will also be acting in downward direction. Now, to understand how it works or to understand about it, you have to mark that there is a tension T that acts on this string, and there is a tension T acts on this string. There are two parts of string. So the same string, but here there are two parts. So here also this tension on this is also T and tension on this is also T. So this load will be balanced by this tension and effort is balanced by this tension. Okay, this will be balanced by this will be balanced by this. Now my MA will be load upon effort T by T, which is equal to 1. Velocity ratio dE by dL. Now this is like an ordinary pulley. If you pull this rope effort by a distance x, the load will also move through a distance x. Do you agree with me? If you pull this by a distance, say 10 centimeter, this will also go up by 10 centimeter because this is the same load. So if this moves through a distance x, load will also move through a distance x, and therefore again VR also 1, and efficiency is 100%. Now this kind of a machine, MA is also 1, VR is also 1. So it's not a force multiplier. It's neither a force multiplier nor a speed multiplier. What is it used for? Just change in direction of force. So I told you in the first video itself, without a pulley also you can draw water, but it will be difficult because you have to apply force in the upward direction. Now with the pulley, you'll have to apply effort in the downward direction. So this system, there is no gain in speed or gain in force So they thought in order to overcome this, single movable pulley was invented. Now why is it called movable pulley? Here the pulley will move along with the load. So the setup will be like this. This is your fixed frame as usual, and to this hook, one end of the rope will be fixed, the other end of the rope will be like there, and the load will be fixed directly to the pulley. Okay, one end of the rope will be fixed to this fixed frame through the hook, the other end is free to move. So you will be applying effort here and load is here. Okay, load will be acting in downward direction. Now this rope will have tension T and this rope will also have a tension T. Is it clear, children? You understand what is movable pulley? Now movable pulley, why it is called movable pulley? As you pull this rope up, this pulley will also move along with the load. Are you able to imagine? The pulley is not fixed. It is free to rotate. It is free to move up and down. It will rotate also and it can move up and down also. So as you pull this rope up, the entire pulley will move up along with the load. So that's why it's called movable pulley. Okay. Now, in what way is this advantageous? Let's see. Another thing. Okay. So L is balanced by, okay, E is balanced by T because this string. Now L is here. It is going to be balanced by these two strings. So T plus T, 2T. Load will be balanced by the tension of these two strings because load is in between and these two will have an effect on this. So L will be equal to 2T, E will be equal to 2T. So MA will be equal to load upon effort 2T by T, which is equal to 2. Velocity ratio. Now in this case, you pull it by a distance x, the load will move up only by a distance x by 2. Why is it so? Because if you pull it by a distance x, there are two parts of the rope. Both of them actually will, the single one you pull it by x, it will be divided between these two. So both will actually move by x by 2 and therefore your load will also go up by x by 2. Okay, in my previous video I have explained it clearly. So velocity ratio will be dE by dL. So load moves through x by 2. If effort moves through x, load moves only by x by 2. So again, this will also be 2. Now this case, it can be used as a force multiplier and a speed multiplier. It can be used as a force multiplier as well as speed multiplier. But what is the disadvantage? Again, force has to be applied in the upward direction. Force to be applied in upward direction. Okay, so to overcome this, what do we use? Combination of fixed and movable pulley. Combination of fixed and movable pulley. I'll just tell you how to draw. So you put a fixed frame first, then a hook here. First will be your, actually it's basically the same diagram, children. After this, you have to put a fixed pulley. So you extend this frame, okay, and then this rope you make it pass through another pulley which is fixed to the frame, and the rope should go here. The rope, the effort which was applied here, it will come down. So you pass it through another fixed pulley. So this is movable, this is fixed, and then the effort will be now applied here. This is called combination of fixed and movable pulley. For this also, MA will be 2 and velocity ratio will be 2. I want you to draw this separately, combination of fixed and movable pulley also. So I think you are clear now. So please write all this as notes and send it to me. Thank you, children.